You're looking at this right now and you're going, ooh, fractions. I don't like fractions. I know you don't like fractions. The good thing is we never have to deal with those fractions. Because what we're going to learn right now is a quick, easy, one-step method to get rid of every single one of those fractions before you ever have to solve it. Now to do that, we have to go back to elementary and we have to remember something called the LCM, which is known as the least common multiple. So the way we get rid of these fractions is by looking at all of their denominators. If you have one fraction, that's easy. If you have two fractions, you have two denominators. In this example, we have three fractions, so we have 1, 2, 3 denominators. We need to find the least common multiple of all three of those denominators. So the least common multiple of 3, 6, and 4. There's a lot of ways you can do that. The easiest way, the quickest way is to do this. Look at the denominators. Which one is the largest? 6. So if you want to find the LCM super fast, you take the largest denominator, 6, and you find its multiples. What do you mean about multiples? I mean you multiply it by 1. What is 6 times 1? 6. So we know that 6 times 1 is 6, and then we ask ourselves a very simple question. Does 3 go into 6 evenly without a remainder?
Yes.
Does 6 go into 6 evenly without a remainder?
Yes.
Does 4 go into 6 evenly without a remainder?
No.
No. So we have to keep going. That does not work. 3 and 6 go in evenly, but 4 does not. So we find the next multiple of 6. All you're doing is multiplying. 6 times 1, 6 times 2, until you find the least common multiple. So we do 6 times 2. We get 12. And we ask ourselves that same question. All right, does 3 go into 12 evenly with no remainder? Yes. What about 6? Yes. What about 4? Yes. All three of them go in evenly with no remainder, so that means that our LCM is 12. Once you identify the least common multiple, that is your key to unlocking this equation and getting rid of all those fractions using simple multiplication. But you have to find the LCM first. So once again, to find the LCM, you take the largest denominator of however many fractions you have. In this case, we have 3 fractions. The largest denominator was 6, and I find all the multiples. As soon as I find the smallest multiple that all 3 of these numbers can go into evenly with no remainder, that's my LCM. Once we have the LCM, here's how we get rid of all the fractions. We're going to take our least common multiple, and remember that what you do on one side of the line, you must do on the other. So the way we get rid of all these fractions is by multiplying both sides by the LCM. We're going to multiply the left side by 12. We're going to multiply the right side by 12. And when I say multiply, I mean, if we look here on the left side, how many terms are in the parentheses? 2 terms. You have 1/3 x and 5 over 6. So we're going to multiply both of those terms by 12. And here's how you do it quickly. You do 12 times 1. What's 12 times 1? 12. Then what is 12 divided by 3?
6.
What is 12 divided by 3? It's 4. So you get 4, and don't forget to bring down the x. 4, bring down the x. 4x. Okay. So we took care of that one. Then we take care of the next one. What's 12 times 5?
60.
60. 60 divided by 6 is 10. That's a positive sign there, so it becomes plus 10. 2 of those fractions are gone. Next side. So I do 12 times 3. What's 12 times 3?
36.
And what is 36 divided by 4?
9.
So I get 9. I bring down the x. Then the last term, I do 12 times 2. That one's simple. What's 12 times 2?
24.
24. Did I get rid of all the fractions? Yes, I did. And now I just have an equation with variables on both sides. We're not going to solve this. Not yet. Right now, all I care is that you guys know how to find the LCM and simplify. We're going to solve in section 2. Any questions? We're going to do some more examples, though. Any questions here on how we did this? Any questions on how we did this? All of this is practice. Some people clicks right away. Some people it takes 10 examples, 20, 30, 40, 50, 60 until it all clicks. Magically one day you wake up, I get it. His name was Harambe. No, you get it. What's up?
Did you get 9?
Where did I get 9? I did 12 times 3. What's 12 times 3? And then what is 36 divided by 4? 9. That's how I got 9. And I brought down the x. Okay? It's good questions, though. Questions mean we're learning. All right. So we're going to do 2 more of these examples. All we're doing here is finding the LCM and getting rid of the fractions. So here we have 2 fractions. That means two denominators. We don't care about the -8. We don't care about the +4. We care about this denominator, this denominator. And you ask yourself a simple question. Which one's larger? 5. So I'm going to find the multiples of 5. I do 5 times 1. That gives me 5. Does 3 go into 5 evenly? No. So we keep going. 5 times 2 equals 10. Does 3 go into 10 evenly? No. So I keep going. 5 times 3 equals 15. Does 3 go into 15 evenly?
Yes.
What about 5?
Yes.
Yes. So my LCM of 3 and 5 is 15. Once I find that, yes?
Can you just multiply? Like 3 times 5 is 15.
Does that work? Would that work here? 4 times 10 times 5, so your LCM would be 200. You want to find something that works for everything. That works in one specific scenario. Doesn't always work. So I'm teaching you something that works every time. For all problems, for the rest of your mathematical career. All right. So we take this, we wrap both sides in parentheses because we're going to multiply both sides by the LCM, which is 15. And it's the same process, kids. 15 times 2 is what?
30.
And then 30 divided by 3 is?
10.
10, bring down the end. 15 times -8 is what? I'll tell you. It's negative 120. Good. Equals. We do the same thing on the other side. We do 15 times 3 is what? 45. 45 divided by 5 is? 9. 9, bring down the end. Then you do 15 times 4. What is 15 times 4? 60. And we've simplified that. Now I'd be able to go in and solve it. And if I solve that, I would get n is equal to 108. But we're not going to solve it right now. We're going to solve that next, after we finish with later. Okay, one more. Now we have 3 denominators here. So let's go to Marcello. What's your largest denominator? 10. So we take the multiples of 10. 10 times 1 equals 10. Does 4 go into 10 evenly? No. So move on. 10 times 2 equals 20. Does 4 go into 20 evenly?
Yes.
What about 5?
Yes.
What about 10?
Yes.
Yes. So that is my LCM. And I'm going to multiply both sides by the LCM to get rid of all these ugly fractions. 20, and that's a 0 over there. That is some type of 0. There we go. Kind of. All right, so we multiply, same process. 20 times 3 is? 60 divided by 4 is? 15. So 15, bring down the end. 20 times 7 is?
140.
140. 140 divided by 10 is? 14. Equals. We do the same thing on the other side. 20 times 4 is? 8. 80. Somebody said 8. 80 divided by 5 is? 16. Don't forget the end. If you forget the end, everything else you have at this point will be 100% wrong. And then last but not least, 20 times 15 is? 300. And that's it. Just simplify. Get rid of them. One step at a time. Any questions on this? Any questions? All right. And move on. So we still have to get rid of the fractions first. So same process. We have 5 and 10. Which one's larger? 10. So we need to find the LCM, and we're going to find the multiples of 10. 10 times 1 is 10. This one's pretty easy. Does 5 go into 10?
Yes.
Does 10 go into 10?
Yes.
So that one was pretty easy. So we multiply both sides of this by 10. Make sure you multiply every term in the parentheses. Don't forget the variables. 10 times 3 is 30. 10 times 4 is 40. 40 divided by 5 is 8. So plus 8b equals. On this side, 10 times 9 is 90. 90 divided by 10 is 9. Don't forget the b. Now that we have the fractions eliminated, we can solve this. And guess what? This is just a one-step equation to solve. Watch. So, Here's what I want you guys to understand. When you have variables on both sides, you once again look at the coefficients. Which one's smaller? 8. So we need to move this over here. What's the inverse of a positive 8b? Negative 8b. So we're going to subtract 8b here. We're going to subtract 8b here. And then we always work from left to right. We bring down the 30. What happens to the 8b's? They cancel. And then 9 minus 8 is 1. And 1b is the same as just writing b. And that is solved. Just like that. It looked complicated up here with all this craziness. But once you got rid of the fractions, it was one step to solve. That was it. Boom, boom, bang, bang. Yes.
So, because 9 minus 8 is 1, you have to put the 1. So
You don't have to put the 1, so it's just b. You've solved it. As long as it's a positive 1, you're done. Positive 1, you're done. Okay.
Doesn't rhyme.
Let's try another one. All right, let's try this one here. So this one, by the way, I want to point this out. I chose this example for a reason. We don't care that there's a negative there. We don't. It doesn't mean anything to us. All I care about right now is the denominators. My denominators are 6, 2, and 4. Which one's larger? 6. So we're going to find the multiples of 6. 6 times 1 equals 6. Does 2 go into 6? Does 4 go into 6? No, not evenly. So we go to the next one. 6 times 2 equals 12. Does 2 go into 12? What about 4?
Yes.
And we know that 6 does. So that's my LCM. So I'm going to take the LCM and multiply both sides by 12. And this is where you got to be careful. If you multiply wrong here, everything else you do after this point will be 100% wrong. So, little arrows help me remember that I've multiplied. So I do a little arrow. 12 times 5 is? 60. 60 divided by 6 is? 10. Don't forget the y. That one's done. 12 times 1 is? 12. And don't forget that's positive, so plus 12. Equals. I do the same exact thing on the other side. 12, and ignore the negative for now. We'll come back to it in a second. 12 times 1 is? 12 divided by 2 is? 6. Now, bring down the negative, bring down the y. 12 times 1 is? 12 divided by 4 is? 3. And we've gotten rid of all of the fractions. And this is what you have to remember how to solve equations with variables on both sides. We look, there's no terms for me to combine. Variable term, constant, variable term, constant. Okay. But I have to get all the variables on one side of the equation. To do that, I look at my coefficients. Which coefficient is smaller, class? Negative 6. So we need to move this here. What is the opposite or the inverse of a negative 6y? Positive 6y. So we add 6y, we add 6y, and we work from left to right. 10 plus 6 gives me 16y. I bring down the positive 12. I bring down the equal sign. These will cancel. I bring down the 3. Looking at it right now, I can already tell my answer is going to be a fraction. I'm totally okay with that. Right now, we still have work to do before we can divide. I cannot divide yet because I have a constant here. I have to get rid of this constant and have this variable term all alone before I can divide out that coefficient. So I do the inverse. What's the inverse of a positive 12?
Negative 12.
So I subtract 12. I subtract 12. Next line, work from left to right. You bring down the 16y. Those will cancel. Equals 3 minus 12 is negative 9. Now that you're here, now is when you divide. When you have a variable term with a coefficient on one side by itself, you have a constant on the other side by itself, this is when you divide out that coefficient. So we're going to divide both sides by the coefficient. Mr. West, what's the coefficient? It's the number next to the variable. 16. So we divide both sides by the coefficient. 16 and 16. That's a 6, by the way. Those will cancel, leaving you with y is equal to negative 9/16. You cannot simplify that fraction, so we leave it alone, and that is my answer. All right.